Welcome to part 2 of the ScPrime XNS roadmap call. This is where we'll review the roadmap as it's listed and shown on scpri.me. If you go there to the website, you can actually do the URL / number symbol roadmap, or just scroll down the page and you'll find the roadmap graphic, which will have all of the stuff we're talking about. It needs to be updated for a couple of reasons. I'll talk about some of them in this call. But ultimately, come hell or high water, one way or the other, we will get through everything that's in these two calls. The times and dates and all of that sort of stuff may be fluid based on certain things that we're going to discuss today, but overall, I believe we're in pretty good shape to pull off what's listed on the roadmap itself. I've been talking about this slide to different kinds of constituents lately than what we normally do, but it applies to everybody equally. If you look at the bottom of that chart, it's 2020 and 2025 are the two data points, and we're right in the middle of that right now. So you can kind of get a sense, of where we are, and we're not very far. Right. But it's really interesting because if you look at that chart and you look at the three bars to the left, that's AWS, Google, and Microsoft, right? I mean, they've made trillion-dollar businesses off of those little bars, right? That's what astounds me about this chart and what people just really can't quite grasp or fathom. That the amount of data that's coming is going to inundate everything that's out there. I mean, it's insanity how much is coming, to these networks. So I literally never worry about there being a zero-sum scenario or will we be able to beat the competitor X or whatever. And I really never worry about whether we're going to get our fair share. It's just a matter of when we'll get our fair share, to my way of thinking. And anybody that disbelieves that hasn't used the relayer yet or tried out the network or done any of that sort of stuff. The network's getting stronger every single day and so forth. So there does seem to be a need from our partners for a small self-contained relayer that you don't have to do anything. You just plug it in and go. And we can actually pretty easily co-brand that, right? We can give the partner the ability to sell this device, and on the front, it'll show our logo, and then it'll also show it'll show their logo, and then it'll say something like powered by ScPrime and XNS or something like that. And then when they go in and pull up the relayer for the customer, it's the lightweight version of the UI. And then at the top on the screen, then, you've got some co-branding again, so it looks like it's their tool, but it's being powered by our architecture underneath and so forth. So small form factor type computers, but, that ballpark dollar number to get the base computer that has 13 to 15,000 or maybe even more pass mark score, 64 to 128, gigabyte of memory capability, and then, some capability to put a decent sized drive in. Now, whether that's SSD, 2 terabyte SSD or 4 terabyte SSD, or whether it's 2.5 inch drive, or whether it's a full on 3.5, or whether it's an external USB, I don't really know. I mean, we'll have to really kind of design that, but there does seem to be some call for that. So we may roll something like that really quickly. It's not the relayer NAS, so to speak. It's more like a branded relayer, so that partners can just quickly get relayers set up, or customers can just buy these off the shelf, plug them in, and have a relayer. They may not need the NAS capabilities that we talked about last week. So this is a bit of an announcement, and we always save that for the people in the Discord. We do spend a lot of time evangelizing and telling people and getting the message out in Discord. And one of the things about that I'd like to sort of drive home with you is it's kind of a responsibility on you guys, right? You're the standard bearers. We really need you retweeting. We really need you out there, creating new messaging, saying, "Holy cow, I just heard this." Check this out. And you guys can be the front runners that get out there and tell the tale before anybody else, hears about it. And so this one's one that you're going to be able to get out there on, because this is a pretty big one. So what ended up happening is that we got to the end of this year, and we knew that we were going to have some cash flow issues. So we've been really trying hard to find ways to sort of solve that puzzle. And all the traditional ways to solve that puzzle just haven't really materialized. And I don't blame or I'm not angry or anything like that. In my view, the deal simply is we got caught, in the wrong side of, economic market conditions all the way around. The good news is that there's green shoots. You can definitely see it with like Bitcoin doing what it's doing, but this is the pre-wave into the Bitcoin halving, and then out of that we'll probably get some more consolidation, and then we'll get the real run up, just like we do every other cycle in the past, which means that we're probably going to see a move up on SCP at some point in time in the next several months, and then we'll probably see a much larger move in SCP sometime later on in 2025, 2026. I don't know exactly when, and you're just going to have to do your own diligence on that if that's something that's of interest to you. But one of the things that we always knew that we had it sort of in our quiver was these SPF tokens. They earn 15% across the entire contracted storage space of the network, and today there's a petabyte and a half of use capacity. So guess what? The SPFs don't earn off much at all. As we get out there with some messaging, we'll start to find our adoption. I think as we find some magic recipes and people realize our tech is different than the other decentralized storage networks, better, more secure, more durable, more control under your fingers, I think we'll probably grow faster when we finally do get some acceptance and we move forward. So, those SPFs have the ability to, fairly quickly become something pretty powerful in the network. But, I think most people have the right time frame and say, well, it's going to be a couple of years before they really start looking, too interesting. But that's cool. That gives me a chance to kind of get them in place now and figure out what I got to do. Well, what ended up happening was, when we built the project, we started out by doing, proof of work forked over a ASIC-driven blockchain. And consensus is nothing to do with a storage network. Essentially, the consensus does, validate 3 places every storage contract, formation, final revision, and then ultimate, storage proof contract closure. So, there is a little synergy there, but, not really. And the ASIC miners don't give a darn about us, and they've proven that over and over and over and over and over again. And so they're kind of this weird little adjunct who are out there generating all this SCP, 55 million of them over the last 5 years. And for the most part, they just don't give a rip about the project or anything that's going on. So if I had to do it all over again, I guess we'd probably still do it with ASICs, but at the end of the day, I just really feel like the better strategy is going to be to tie the storage proofing into this consensus generation. And what we will do is we will create a bridge, and the bridge will be a place where SPF will go in, and then they will get turned into something called WSPF. And those WSPF will be contractualized on Ethereum to begin with. One of the things that moving this up really rapidly the way we did, or not rapidly, but to immediate future, was we've had to make a decision to try and do this in the most basic sort of way. I mean, there's a lot of things we could do, but essentially what we're going to do is we're going to drive this out really basic and just get it out there, because we can do smart contracts and even like an IDO type scenario on a launch pad, if that's what ends up happening. We can do a whitelist period if we need to do something like that. We can do token generation, all that stuff's really pretty simplistic, not too hard to handle. It's really generating the bridge itself. The bridge is a centralized thing. It's a kind of like a watchtower wallet. Some of the questions that might come up, well, so you send A and B in there, what happens with, A's claims and what happens with B's claims since they're no longer, tied to a provider. And originally we talked about actually providing claims on the corollary blockchain, Ethereum in this case. But ultimately what we've decided is, in year one, it isn't going to matter, right? Nobody's going to be buying these on the DEX, Uniswap, to essentially earn SCPs, because why, right? I mean, let's say it's 6 months from now and, there's 15 petabytes of used capacity on the network. Guess what? They're still not going to be making very much SCP at all. And what'll likely happen is towards the end of next year, when we move and change to a different consensus, these tokens will be the foundation behind that consensus. So the contract will change. Maybe WSPF will get all burnt and converted over into some other new token name. But the deal, will be that the SPFs that you own will become the consensus generators, the new ASICs on the blockchain as we go forward. And so the big reveal today is we're getting started on the bridge right now. I expect that we will launch a wrap token on Uniswap no later than, say, January of this year, or at least be well on our way to listing in January of this year. The problem, why we've had such a problem there, is because when we tried to list on places like Binance and, whatever, they just rejected us because the volumes are not there. They just didn't see it. And we didn't have the mechanisms in place to pay for the market making that would bring the volumes around to be what we needed. So, we didn't do it. And then, we tried to do the strategy like Helium did, which is you list on a mid-tier exchange and then you work your way up. Again, there was no project funding for market making to keep the volumes up on the exchange, and that pissed the exchange operators off. DEX doesn't work that way. DEX works through the case of, anybody can set up a coin with no big listing fee. Essentially, as long as you can attract liquidity pools, you can bring people in that want to trade a new coin. They'll come in and use it. They can trade it on ETH, and, it'll be a thing that will allow people that heretofore maybe didn't want to participate in the project get participating. And what, you can sort of hope from that is that two things will happen. One is, who knows, we might, get overfunded, right? We might get more than we kind of want, right? Because we don't want very much. We want a very small amount of money right now, to be frank. And if we get a little bit more than a very small amount of money, then we could turn around and perhaps end up getting the market making that we've talked about if we were to get VC funded. So that would then lead to Coinbase or Binance or whatever big exchange along with liquidity provisioning. So, that's one way that SPF exchanging could benefit SCP people. The other way is that, those people that come in and, sort of look at, the ecosystem and really start to learn about it by trading SPF say, oh, hey, this is pretty cool. I'm going to get involved in this. Yeah, they got shitbox exchanges, but it looks like they got a plan. So, I'll dive into this, stand up a bunch of EXA miners, become a partner, talk to their company, get storage in here, buy a bunch of SCP. I mean, there's just 100 ways that doorway can turn into marketing that ends up coming in on the project. All right. I've took a long time on this, but it's such a major thing.
I did see in a different channel a little bit of maybe opposition to choosing ETH for an SCP bridge just due to transaction fees. So can we speak a little bit about whether we see transaction fees as a barrier, as a problem? What do we expect?
Yeah, I'll say right now that we're not 100% on ETH yet. It's close, but it's probably not 100% yet. We could choose a layer 2 on top of ETH, for instance, right? Or we could choose Solana, or we could choose some other deal. But nothing's stopping us right now from choosing Polygon or another L2. That's what's going to come That's what'll percolate up over the next 3 to 4 weeks as we roll the bridge. The bridge part, the part of building the bridge that he's working on right now is going to take a few weeks, that he's got to get that all done. So we can kind of just keep researching and doing our work right now on the other side of the coin to understand how, we're going to distribute, how the LP is going to work, how the, marketing is going to work, how the distribution is going to work, how the whitelisting is going to work. And then ultimately what coin, what chain, what, launch pad, if we do that, whether it's, Pancake Swap or whether it's, Balancer or something like that. I don't know. We've got a little bit of time ahead of us to really do more of that homework. But I just have this sneaking feeling we're going to end up on some flavor of Ethereum because it's just such a well-developed and easy to essentially build coins and contracts off of that it'll be, almost a foregone thing. The worst thing that we could do is try and get really esoteric and then ultimately have, our contract hacked.
This is something that's been on our radar for a little while, but we have a pretty good sense of how to actually implement it at this point. We looked at a couple different technologies like WebRTC. MQTT was another common one that's common in like smart home kind of things. But we're going to go with a WebSocket-based implementation. It turns out that the way that we've constructed our Relayer UI and our refactor for the Xminer UI that's coming is actually very compatible with this kind of WebSocket implementation. So it would take some engineering in Relayer and Xminer UI and a little bit in the backend, like in our console. But overall, not actually too big of an effort. And what it allows is really cool. So that means from the console, so we've already, over the duration of the console's been around for, a year and a half, 2 years, we've been pushing more and more into the console, and that's going to be the direction things continue. So we already, in the console, you can see your storage provider, like your Xminer licenses. For Relayer use, you can see like all sorts of cost center statistics. You can see particular like Relayer usage, that kind of thing. And that's just going to be continued and expanded on. So we're aiming to get to the point where through the console, you can securely actually access directly the Relayer or Xminer user interfaces. So that means you no longer have to hop into Chrome or whatever and pull up the local IP address on a specific port and then go through that whole dance. You'd just be able to do it securely through the console, which would be awesome. Of course, security is at the top of our minds as we do this. So we expect to also implement like two-factor. We're expecting to implement two-factor anyway, but additional security authentication layers for specifically the Xminer and the Relayer, because these are pretty important things that you want to be sure that the only people who have access are the right people. And this is also really useful for partners. So we talk about how partners are setting up relayers at different locations for different clients. This would be a pretty like native and built-in way that they can access these relayers and make any tweaks or for whatever reason they might need to log in. Although they could do that already kind of using a VPN and remoting in, this is just a pretty awesome way that's directly built into the console and is using technology that's already kind of mostly there. So that's really exciting. And then remote support is kind of the last thing. So that remote support, I guess, from the perspective of a client with a partner, I kind of touched on, but there's remote support as well that could be possible for the Xminer and kind of storage provider side. So right now, I'm sure anybody who's been through support, we do an awesome job of talking you through what you need to do. But what would become potentially available for maybe escalated kind of situations is the ability to actually kind of hop on a shared call or something and actually directly go over some of, I don't know, folder, like some of the folder editing that needs to happen in the Xminer full license. Like it can get a little silly. So we'd be able to help and assist people better from that perspective too. So really looking forward to remote access coming to the relayers and storage providers.
We did roll out actually Freshdesk into our environment, and It is set up now so that if you send an email to support now across, XNS or XMiner, that it all goes into a Freshdesk ticketing system. And, we haven't been really religious yet about pushing people from the Discord into the ticketing systems, but that's coming, by the way. I mean, it definitely will come in the future and to drive into that. But part of this remote thing is that, all of our UXs and all of our UIs will be able to get a chatbot that'll ping a live support tech during certain hours. Your XMs, your relayers, your console situation will all end up having a chat, down in the lower window. So imagine chat tied to remote access. Now all of a sudden we're going to have really an industrial strength ability to support our customers. And I think that's really going to be something that's, going to be wonderful as the XNS product really rolls out and we start getting exponential number of miners on the network as the network grows. So, just to back up the overview here so you get an understanding and remember how it's all sort of set up. So the way we're different from everybody else is that we did this Web 2 to Web 3 evolution, then revolution thing, right? Because our belief is that business customers, SMEs, enterprises aren't going to want to do crypto custody. They're not going to want to buy coins. They're not going to want to go through all that sort of stuff. So, and that may never change, by the way, in my view. I think that there will always be some percentage of our customer base, could be a very large percentage, could be a medium, I don't know, but there will always be some percentage that just wants to do that standard cloud operational sort of footprint, and they don't ever want to do anything with crypto. And that's okay, and we have that. And the way we've done that is we've built a decentralized renter tool, which is called the Relayer, right? And so that whole thing gives you the control such that when you start to use the Relayer, we never see your data. We never see your metadata, right? What ends up happening is, you choose the providers to make your virtual private data center. You upload that stuff to the network. And if you choose 500 providers or 1,000 or the whole network or whatever you choose is your VPD, that's what you do. We never see it. It just goes directly from you to the network. And then ultimately what ends up happening is, you have to keep track of the metadata. Now, the same thing happens on the XMiner itself. As you get contracts and storage and stuff in there, you're also keeping a metadata footprint on those devices. So we have these two places where metadata is being shed off and it's always being updated. It's under continuous revision. So the problems that happen whenever a crash happens and you lose metadata because it turns into a pretty challenging scenario. So what we did in that's different to allow us to be able to maintain a standard footprint for businesses is that we implemented a centralized contractor, right? And so that's called Conductor. So Conductor is sitting out there and essentially, contracting with the whole network, right? We're contracting on your behalf is essentially how it works. But the deal is that for us to go from Web 2 evolution to Web 3 evolution, what we can do, or evolution, revolution, what we can do is we can push out, smaller pared down versions of the contractor to the customers that want to do their own, purchase of crypto and, feeding the machine, essentially to get that contracting done on the specific relayer that they're doing. And then we'll have the full decentralized Web3 thing. I mean, it's trivial for us to get there, right? In the Conductor, we don't see anything, right? And that's a problem, right? Because, we don't want to see your data and we don't really want to see your metadata. We're really understanding this. We need to know sector IDs, right? What happens is when you run the relayer, there's this thing that we talk about called indexed rows. It's 480 megabytes. It's 120 pieces. What happens is the data gets sharded into those pieces on your machine at your facility, right? Which is ultimate security, ultimate durability, and then gets provided out to the 120 nodes for that indexed row. And then what happens is that there's a tiny little bit of metadata generated that says this 4 meg segment lives on this provider, and not only on this provider, but on this drive, and not only on this drive, but in the sector ID. If we can capture that data into Conductor and store that metadata piece of sector IDs, so that you can reconstruct contracts that fail or reconstruct contracts that are not, that are corrupted or things along those ways. It'll give us the ability to allow people running examiners to be able to put a query out there, say, look, I've been able to restore my contracts up into, 8 hours ago, which is when my thing crashed. I'm willing to trust you on that 8 hours. So please download and tell me what you show is happening in those 8 hours, and it'll be, memorialized on the blockchain. So that's for the Xminer side of the house. On the other side of the house, what we're going to probably do looks a little like this. Once we get that sector ID thing down and we can really identify where things live, then what will end up happening is we can add a table to the on-site Postgres database so that those sector IDs come down and get stored, and then we can aggregate those, the relayer can aggregate those for you and keep updating them as, you keep uploading and downloading and, doing all the stuff you're doing. But it's a small little, chunk. It's a small little, footprint of metadata that you'll have there just for those sector IDs. Part of what we're going to do is re-architect around this little piece that's coming off on the relayers so that ultimately we can take those pieces off that are coming down for just sectors, and they will not actually be generating their own metadata, but we will push them up into Conductor itself, right? So that you'll be able to have them somewhere, right? So that's the first strategy that we're talking about. So you take those sector ID bits, I call them bins, but they're going to get a name at some point, but you can push them back up into Conductor as one possible way to do it. But that's centralized, so you might not want to do that. And if we push Conductor out to you, then it's like, well, if your relayer crashes, all gone. So that's not the way to do it. So then you're back to needing to run high availability Postgres, blah, blah, blah. So what you can do there then instead is a potential secondary strategy that we'll do is that little bin of sector IDs, and they're always growing, and they hit a certain number, and then you have to do another one, and you have to do more than one, depending on how much data you have out there online. Those things can then be thrown into a decentralized messaging network. And then what do? You get a seed, a little key, a little, passphrase in order to be able to access that decentralized message. You go grab that, pull it down. You can reconstruct your relayer from any point in time, and you're good to go. The one thing that we did change that we do have an engineer working on right now, or we have him skewed up to where he's not working on it right now. But the thing was, when you put in an examiner, the whole SIA protocol was really weird about how it dealt with multiple drives on storage providers. In essence, what it would do is randomly put bits onto different drives. I mean, there was no rhyme or reason to it. And instead of adding extra durability, that created extra lack of redundancy, because it's like turning a 4-drive machine into a 4-drive striped RAID. Right? Lose one drive, you lose the whole contract. I mean, it's like, how does that even make any sense? So we immediately shut that down when we set up our stuff. That's not doing that now. It's all going to the first drive on the deal. That's not very robust or durable at this point. We know that's what this metadata exercise is about. But the exercise that we're going to do is going to be to split up sort of, in an intelligent way, how the data goes into the drives and how it continues to go drive by drive by drive. So one of the things that's really clear is it doesn't make sense in a 20 terabyte drive world to have one contract for one 20 byte drive or terabyte drive, right? That's a lot of data at risk under a, single contract that can get corrupted for no other reason than the power went out. We will work to likely split contracts per drives into, maybe there will be a contract every 2 terabytes or a contract every 4 terabytes or something along those lines. And then ultimately what will end up happening is, a big 4-drive 64 terabyte rig could end up having, 50, 60 contracts or even more, depending on how it all gets done. And, that way, if any contract goes corrupt, potentially, it just takes down one tiny little bit of your storage and you don't lose a lot of money. See, I'm thinking out several years about what it's going to look like when you have a lot of data on these machines and you're really freaking out every day thinking, oh my God, if this thing crashes, I'm going to lose like $300 or $400 a month. I'm terrified. So we already are thinking about how we're solving those problems in the future for you.
So kind of continuing in, I guess, thinking about future kind of disaster situations, trying to get ahead of them, starting the engineering now, or at least soon, before some of these kind of edge cases or esoteric issues become like a real issue. We're also looking at file repair. So we've talked before and at length, just not recently, about some of the effects of churn and what that kind of means for our network. But and I've also talked plenty about erasure coding, so I'm not going to go too deep into it. But the numbers that we're at today, we use like an 80-120 ratio. So that essentially means that a total of 120 pieces are distributed to ideally at least 120 different storage providers from each row. And of those 120 pieces, only 80 of them need to be pulled from in order to reconstruct the file. So that gives you a margin of those other 40 storage providers, I guess. Anything could happen to them and you would still be able to recover and read your file. But there's a ton of considerations that go into this. And this is really kind of at the heart of engineering on our network and our protocol. And so there's some really interesting issues, actually, that I've kind of enjoyed chewing on and working on. But something that we know we've needed for a long time and has been identified since the beginning in the white paper is what we call active file repair. So right now, data is distributed, and that's very good. The erasure code ratios that we've chosen factor in all sorts of things. But if you're looking at this from kind of an engineering perspective and trying to optimize the network as much as possible, you actually want that erasure code number to go as lean as possible. So we're at 80-120 right now. The closer those two numbers can be together, the more efficient the network kind of is, or at least there's a lot of efficiencies in that you're not duplicating data more than you have to, which is foremost, that would be cheaper to do. But at the same time, it would allow the network of a given size to serve more capacity. There's just all sorts of benefits. So we would like to lean the EC ratio because that makes everybody happy. But the only way to kind of do that and still maintain the 11 nines of like redundancy and availability is to start leaning on active file repair. So that means that the relayer itself, it's already and has from the start been keeping track of every sector that it uploads. It knows what storage provider it's sending that to. It knows what part of the file that was. Like, it has all that metadata already kept within the relayer. And what active file repair is doing is essentially every once in a while it would reach out to different storage providers and it would just see if it really has that sector that handed it still. So 3 months might go by and it'll check on that storage provider and challenge it and see, hey, do you still have all these sectors that I gave to you? And if it will ideally, and what'll happen almost like the vast majority of the time is that the storage provider says yep, and it can maybe provide some proof, and then everybody's happy. But occasionally, the relayer will either just not get a reply from a storage provider, and it'll just assume that it's MIA, and it maybe can't count on seeing that particular sector again. You know, like there's still enough storage providers to be able to fully rebuild the file and serve it, but it's not as much of a margin as I would like. You know, maybe of the 120, maybe 100 are left, and you need 80 to rebuild it. What the relayer could do at that point is it rebuilds that file, it pulls the 80 pieces from those storage providers, and it reaches out to new ones and uploads new pieces to kind of reseed those original 120 sectors. So that would be really powerful. That's awesome. That's something that we know how to do. It's been in the white paper from the beginning. That is very much at the core of our protocol. So we have provider churn on the slide. So how does provider churn factor in? What drives storage providers to maybe accept a row and then a couple months later flake out and not have it anymore? The foremost example is just storage providers leaving the network. So that does inevitably happen sometimes. for various reasons. In those situations, it kind of just sucks for everyone. So typically, whoever's leaving the network, there's some penalty to leaving, or they're going to ultimately fail their contract, whatever. So it kind of sucks for them. It sucks for us because we were counting on having that data. We're now not very happy that we gave it to them in the first place if it turns out they're just going to leave. So it's bad for everybody. And the more people that do that, the more we have to increase those kinds of ratios of maybe if churn were like a massive issue, then instead of 120, we might have to go to like 140 or 150 or something. And that has inefficiencies, like I talked about earlier. You want to be as lean of a ratio as possible. So nobody wins from that. Churn just sucks. It's really efficient for our network. It is inevitable to an extent, so you have to anticipate some, but we try to do everything we can to minimize it. That's what licenses also helped achieve. So we didn't just want people to be treating storage providing like they would treat ASIC mining or GPU mining or something, where you can just pop up, do it for a little bit when it's convenient, and then disappear. Our churn rates, at least like over the last 12 months or so, have been pretty good. But even still, it's a constant battle. There are still people churning. It's not something that you can declare victory over, but things are pretty good at where they are now. And file repair will continue to provide assurances. So I'm looking forward to ours coming to the relayer, doing it right, and not leaning on it too hard, because the active repair itself is also expensive. So because you're pulling the full file from all those providers and then putting it on new storage providers, it should be avoided as much as possible. But when you do need it, you really need it.
I think there's a vision thing there, and one of the things you can look at other projects and so forth. If it's a totally decentralized project, in a lot of ways they don't really care who provides and how, and it's just everybody piles in, and it is what it is. But I think the whole helium model continues to attract in terms of our visioning, because with helium, what ended up happening was they sold these million nodes or whatever it was, but look, it was $300, $400, $500, $600 to put a node together, and it may not be a lot of skin in the game. It is still, you spent money on this thing. Whereas if you have a computer that already has some storage and you can just fire up Chia and do that, or you can then do storage next week, and then you can go over and do Psi or whatever, that's just really not a great strategy. And the deal there is as it does happen, these what are called decentralized physical infrastructure networks, DPIN, they're going to all be vying for the same resources, right? The same bandwidth, the same, all of the same stuff, even the same shelf space in somebody's domicile or building or whatever. Well, the thing about that is that, I think there's a finite number of people that will build computers to put onto these things. And I think that finite number is going to get distributed between a bunch of different projects. And so, then I think what's going to happen is there's going to be a much larger number of people that'll buy like a Helium node, or they'll buy like an Examiner, or they'll buy like whatever. And if we get smaller flavor Examiners, or we get, different kinds of Examiners, that'll just, enhance it. When we get more manufacturers building them, that'll enhance that. So I think what'll end up happening there is that you'll get a lot of people onto this network when it's all said and done, and it'll be a very robust network. Xminer Xtreme was this deal when we thought we were, going to be able to do a little more than we ended up being able to do over the last 6 months, and this quarter that we're in right now. We really believe at some point that we will dive into compute, right? But compute needs its own sort of special thing. Yeah, I mean, in Examiners maybe can do it in to a degree in our current instance, but probably what's going to happen is we'll have a new generation of miner that will come out that will be able to take advantage and drive that side of the house as well. Because what needs to happen there is the focus needs to be more on the GPU than it does on the storage. So I don't know. We may have combo miners, but we may not. We may have, compute miners, and may have storage miners. It really depends on what the technology reveals to us is what we can do. The one thing I do know right now is it's probably a good thing that this got pushed back, because what's happened in general, and I've seen this so many times, in my life, it's like that right now because of AI. and AI is just swallowing GPUs. So you can't really go out there and easily acquire the kinds of numbers that we're talking about. Compliance is one that comes up quite a bit. And, for the longest time, I didn't know how to answer this. And in truth, I think that I've really kind of got the right answer now for it. Because when you really get down to it, it isn't the same for us. It isn't the same for us. First of all, let's just take one out of there right away. PCI DSS. Well, we already have that. So, that's credit card stuff, how you store credit cards and, your security and all that stuff. We don't. So, that's turned over to a third party and they pass. So for us, that's completed. SOAK 2 and 27001. And then you get into more granular things like HIPAA and stuff like that. So, for SOAK 2 and 27001, these are primarily things about how you run your business. And here's the thing. When you send data up to Amazon or Wasabi or any of these other places, or even to, some of the people in crypto that are having edge caches and, you send a full copy up to one place. What ends up happening is they need to have this SOAK 2 and 27001. Storage needs it. They've got your data goes to these satellites that are corporate owned, right? So before that's where it gets chopped up and sent out from, right? So they need this. They don't have it, but they need it because that's where you're going to get hacked, right? That's where the black hats are going to show up and take your data away from you. So in our case, we don't have that. We never see your data. It never touches us. It never comes to us. Your metadata never comes to us. Your metadata and data start at your facility. You choose the data providers it's going to go on. You encrypt the data at your place with military grade encryption, right? 256 AES encryption. So essentially, if there's been some development that's been hacked, I don't know about it. And at the end of the day, you shard it and turn it out to, 120 providers for this 480 megabyte row. So at the end of the day, you might be having data live on 500 different providers, all encrypted in tiny little slivers. So even if you could bring all the paper back from the shredder and set it on the floor and do that exercise of piecing things together, it wouldn't do anything because it's encrypted and you can't get to it. So it doesn't need SOAK 2 or 27001. It's literally unhackable, right? It cannot be hacked. Now, I'm very clear to people that, if you set up this cloud doorway inside your facility and then you give people access to the cloud doorway, well, that's a place that you can get hacked. But same as you can get hacked on your local desktops, your VMs that you're running, or same as anything else that you're doing. So at the end of the day, the only business processes that you really have to monitor us on is payment stuff, PCI DSS, and potentially some of the stuff related to SSO that we're doing on the console. So I'm not hand waving this away and saying we'll never do it because we don't have to, But I am saying that any partner that comes to me and says, well, I can't sell your data because you're not this. Okay, fine, you're not a partner. Yeah, because you're just wasting our time telling us what you can't do. Because plenty of people will understand the message correctly if you get out there and sell it right. So, at the end of the day, this is our overall technological advantage over everybody else, by the way. Virtual private data centers, data never comes to us. We don't have central control of your data. This is our expertise. This is where we're better than everybody else. We better be able to see some benefit from that. Otherwise, why are we doing it, right? So that's kind of the deal that, we put into place there. And so will it happen? Yes, it'll happen. Probably, I'm guessing now at this point, it'll be Q2 of next year. I'm guessing that there will be, as we grow up, there will be some, universities or, even bigger SMEs or, small enterprises that will come in and say, well, look, we get it. We understand the message, but it's in the charter. We just can't use you if you don't have that seal on your website. Yeah, I understand it doesn't do anything or mean anything, but my boss won't cut the check to you until that's there. So we get it, and that will be there, but it'll be there when we need it. And right now I do not perceive at this point that it's that high up on our priority ladder, especially considering all the work that we've got from these 2 calls that we've just gone through. We had an aha moment over the last quarter, I guess you'll call it. And that moment was, if you set up a relayer, right, one of the things that happens is you get a Postgres database, and that Postgres database is spitting out all that metadata we talked about. And, what you don't really leap to, but maybe you should, is that, well, if I upload a bunch of metadata or a bunch of data and I get all this metadata, why can't I just take that copy of metadata and instance it on a machine 800 miles away? Won't they have access now to all that data immediately? And the answer is yes, they will. And in fact, you could have it in 2 places. Now, from there, it becomes 2 new instances, right? Each one creating their own metadata. So we have some things to do on the back end if we ultimately want to, turn it into true CDN. But at this point, just being able to have multiple people be able to access a large data set. Well, think about that. One of the things that, you typically talk about when you get into AWS, because you have to upload to a single location in your facility, maybe you have, 2G or 10G or whatever, but still, it's takes a week to upload because, the connection is to a single location, no parallelism, and it's just slow. And the internet in between you is there. Maybe you're 2,000 miles away from their data center. I don't know. But in our case, we know that the network runs really, really fast if you have a blazing fast deal. So what can happen is partners or us or, somebody can stand up a specialized, facility and say, well, look, we'll be your sort of locational snowball, right? Where essentially you can go ahead and send a NAS to us, or we'll send you a device, you send it back to us, where you've uploaded everything over a, in-house 10G connection to this device, then you bring it to us, we plug it into the network, we upload to the nodes that you specify on our, really super fast set of pipes. Maybe we got multiple pipes and they're, parallel together or whatever. And then after we get it all uploaded within a day or 2, we charge you a small fee, and then we turn around and ship you back the drive that has your metadata on it. Now, all of a sudden, you plug that into your relayer, and there you are. All of your data is uploaded. Amazon has multiple products for this. They got these little things called snowballs and snow cones and snowmobile. And a snowmobile is a literal semi-truck. It's literally a semi-truck that comes out to your facility with a shed load of servers, right? So, there's ways that we're going to be able to skin that cat using this sort of concept. And then, as I said, CDN is sort of an extension behind all of that. The one piece that we still have to do some work on, we talked about it, a year ago, was this potential way of being able to work from home and being able to have metadata handed over to you so that now you have, employees that all have small little shards of metadata, relayers running on, laptops even, because they don't, need that big of a machine to do what they're doing, their own specific workflows to access the cloud. So, that kind of a thing is how we kind of build that in. Thanks for showing up. Appreciate it, everybody. And we'll see you next time.